Hi, in this lecture I'm going to show you how to use this 7-segment display, which is arranged in a clock configuration and uses an I2C backpack. And first of all, why you'd want to use an I2C backpack? Well, if you don't, a similar clock 7-segment display looks like this. It's got a number of pins that you need to figure out how they affect the various segments on the display, and then each one of those pins would require its own unique GPIO on the ESP32. That's quite a lot of them. It's 1, 2, 3, 4, 5, 6, 7 on one side and another 7. So you need 14 wires to drive this display. So it's quite a lot. Instead, we'll use a similar display, but this one just uses a I2C interface, so it's just 4 wires. We'll be able to control everything that is displayed on this 7-segment display. This particular display from Adafruit also gives us the ability to choose its address by shorting these jumpers here. So if you have other I2C devices and a potential conflict between them, you can change the address of the display just by soldering the jumpers. So I'm going to plug it in and then reset my board just to start the counter. In the example that I'll show you, I've got a simple sketch that just implements a timer. So every second the display is updated with the next number up, and this counts minutes and seconds up to 99 minutes. Wiring wise, things are very simple. Now we've got the I2C interface, and we'll just connect ground from the display to ground on the ESP32. For VCC, we're plugging in the VCC pin to 3.3 volts on the ESP32, and SDA will go to GPIO 21, so that's the data pin, and then for the clock we go to GPIO 22. And these are the default pins for I2C on the ESP32. So there is SDA and there is SCL. So with that, the wiring is done. Let's move on to the sketch. So in the sketch, we're using the wire interface, of course, and then the Adafruit LED backpack library, which also requires the Adafruit graphics library. So these libraries you can get from GitHub, or you can install using the libraries manager. This is the location of the LED backpack that implements the functions that we'll be using, and you can find the URL to this repository here in the sketch. So if we go inside the header file and have a look at the bottom of this file, so down here you'll see the public functions. There's a bunch of print functions or println, which we'll be using. There's also, if you want to write numbers, there's the write digit rule or write digit number. This is the one that we actually implement in order to write numbers. We can also manipulate the column that's right in the middle. I've got blinking here every second, and then the print numbers, print float, and error. Concentrate on the write digit num function, and you'll see that it takes first an integer that indicates the position that we'd like to control. So position depends, the position refers to which of the digits we want to manipulate. So this one is 1 of 4, and the next parameter is the number that we want to write. So that's 0 to 9, and in the third parameter we can also omit, we can manipulate the dot. So every digit has got a dot right next to it, and we can turn that dot on or off. By default it's off, so if we don't provide a third parameter in our sketch, that dot will remain off for that digit. So have a look at the rest, and you can of course experiment as always to get a better feel of what each of these functions does. Let's go to the sketch and have a look at it. So as I said, this sketch implements a timer, starts counting from 0 until you turn it off. And most of the code is actually there to support the timer functionality. So the timer, the previous millis, which allows us to update the screen every second. So that's the interval. So these two, the previous millis and interval, work together. Then I define the seconds, so how many seconds are in a minute, and then how many minutes are in an hour, and so on. And I've got the number of seconds and the number of minutes calculations as macros. The default address for the I2C interface is 70, although, as I said earlier, you can change that by soldering the jumpers, the back of the display. And this is where we initialize the clock display object for the 7-segment display. And let's see, I will create the object here. In setup, we start the display, we just pass the display address. And from this point onwards, we can start writing to it and manipulating it. So inside the loop, the main thing that is happening here is to blink the colon every second. So that's what happens every 1 second. So once we have 1000 milliseconds elapsed, then we'll go inside this segment and flip the state of the colon variable here, so that when we go and then call the print timer function, which calls this function here, we can update the colon display plus the numbers that are displayed. I'm not going to go through this in detail, since all these are calculations that are required to help update the numbers that appear in each of the digits, to make sure that these appear in a minute and second configuration, and then to manipulate the blinking colon in the middle. We also have a bit of code here that fills zeros whenever a number of seconds or of minutes is a single digit. So we add a filling 0 in the beginning. So for example, I'm going to reset it, start from the beginning. You can see that we've got 1 second here, we've got 3 zeros, and that is because this third condition is true. We've got less than 10 seconds, so the first 3 digits are 0, and so on. You can take your time to go through this code and understand exactly how it works. Now, once we write digit numbers and configure the state of each digit, then we need to call the write display function on the clock display object, so that we can print the appropriate digits here. So unless you call the write display function, the information that you've written to the display stays in the buffer and it doesn't actually go out on the display. So that's about it. It's, as you can see, quite simple to control a 7-segment clock display using the I2C backpack. So in the next lecture, what we'll do is learn how to control an 8x8 matrix display, LED display like this one, also using a serial interface. This one is SPI, though not I2C. But first I'll show you how to use a single 8x8 LED matrix display, and then put a bunch of them together to create a larger display that contains 4 individual matrices. So let's check that out next.